Hi, and welcome to this video tutorial where we're going to look at the various different data types that you can find in Microsoft SQL Server. Now, a lot of these data types will be applicable to other databases as well. However, there are a couple that you will find only in SQL Server and you generally won't find in other databases. This video is part of a series of videos where we will teach SQL to beginners, and it will teach you through all the basic areas that you need to know in order to be reasonably competent at writing SQL. I also have another series of videos which is a complete course in SQL, and I'll put a link to that at the end of this video, and that will go into more advanced topics and in more detail about all the areas that we don't cover in these series of videos. But let's get started and have a look at strings. Now, strings are often only covered by one data type in other languages, so you might have a data type called str or string, for example, but in SQL Server you have a few more different types of ways of storing a string in order to focus on improving efficiency of data storage. Now, the first type of character string that you might want is to say that you want a char, and you can specify a length for that. So you might say you want this to be 10 long, for example. Now, incidentally, that's not the length of the string, that's the byte size, so that will take up 10 bytes rather than 10 characters. But actually, there often ends up being almost a one-to-one mapping with them, so you can almost think of that as being 10 characters, but it's actually not. So what that says is it has to be exactly 10 bytes long. So it cannot be more, it cannot be less. If you have a character which is less than that, then it will pad out the rest. It will store more information that you actually need. However, the benefit of that is that it's faster when you're executing queries. So if you have a where clause, for example, it's faster to actually filter records on a chart column than it is on other columns, although it does take up more space. The next type of thing that we have is a VARCHAR. So that is a variable length string. So this time it says that we can have a variable length. So if you have a string which is less than 10 bytes or 10 bytes long, for example, then it will actually reduce the storage volume that it keeps. The disadvantage is it's slightly slower than a char when you're filtering data, etc. So then the other thing that we can have is an NCHAR, so let's write that. And the difference between char and NCHAR is the ISO structure that will be formed. So that may allow certain different types of special characters to go in there compared to char or NCHAR. So you generally have more choice with NCHAR than you do with char. And similar to the char, it's fixed length. So if you say that you want a 10 byte long NCHAR value, it will always be 10 bytes. It's not going to be less or more than that, even if you have something which is smaller than 10 bytes long. And then it has a matching NVARCHAR. So if we write NVARCHAR, and that does the same thing as the VARCHAR in that will reduce its size if the text you're trying to store is actually smaller than 10 bytes. And then we've got another two, so you can just max out. So if you want to, say, store a whole file of string values, etc., then we can just say varchar, and we can put max in there, and that gives you something like 2 gigabytes of storage space. So that should cover most needs. And there's an equivalent NVARCHAR one, so that will also give you kind of 2 gigabytes of space. So we have this set of char values and this set of NCHAR values. We've got 3 variants of it. We've got a variable, a fixed length, and a maximum value. So these are really common, and these are your string values that you'll typically use when you're writing SQL. So let's look at our numerical data type. So let's say, well, let's just label these string to start with so we don't get confused. We'll say string, and we'll label these numeric. Okay, so these are a bit more familiar to what you might be used to looking at in other languages. So we can have an integer, so that's whole numbers, so that's 1, 2, 3, 4. We can have decimals, so let's write decimal. Now with the decimal, you need to specify how many digits do you want to have before the decimal place and how many digits you want to have after. So the most common format I use is I use 18.2. So that means I can have kind of monetary values, for example. So I could have £1,000 and say 2 pence, for example, and that would allow me to kind of store that type of format. Now, decimals are good to use because they're precise. If you multiply and divide decimals, you end up with the same value again. That's not the case, however, if you use float values. So float values are actually not incredibly accurate. So if you're doing financial type transactions, you generally want to avoid float values. There's probably a whole topic on computer science I could talk about on, and some maths we could go into on how computers work with decimals and how they work with float values. It's probably another video in itself, but you can just assume that you don't always get 100% accurate answer with float values, but you do with decimals. So if you're doing finance, then use decimals and not floats. And in fact, there are some recorded instances of people who are working in banking who committed fraud by noticing that because they'd used the wrong data type, they were using floats, there was actually little bits of money left over all over the place, and they're actually able to siphon that off and put that in their own bank account without anyone noticing, because the system never calculated it correctly. They were eventually caught, of course. Other types of number we can have are real values. So they are similar to floats. And then finally we can have money, which is essentially just a decimal, but with a understanding of whether it's a pound sign or a dollar sign, etc. So the most common ones I tend to use are integer and decimal values. Okay, so maybe we want to store some files, and to store some files we need to use some binary data types. So let's type binary. And the first data type for binary is going to be exactly that. It's going to be binary. And that will enable us to store files and images, for example. So there are some depreciated data types which are the image, etc. But they're sort of still about, but I'd recommend not using those. If you want to store an image or you want to store a file, then you need to use the data type binary. And this has a similar format to our string type or our char type values, where we can have a binary and a var binary. So a binary will be an exact length every time, but we can also have a var binary, and on this time we can specify the length. We can also have a var binary max, so if we put that in there and put max there, then again that will allow you to store large files, and I think it's up to about 2 gigabytes. That does tend to change sometimes between versions or between different instances of SQL databases, but I think in SQL Server it's about 2 gigabytes. So if you're storing files or images, then you want to use the binary data type. Next we have dates, so let's put dates in there as our section. Okay, so there's a few different date time formats that we can use. So we can simply have date, and that will just store the date part. If you had a date time, for example, it would knock off the time part. It would only store the date part of that. But you can also have date time, so we can have date time. And there's a particular peculiarity in SQL Server between date time, is that it only actually stores dates that go back to January the 1st, 1753. Now, why they picked 1753, I'm not entirely sure, but they only store dates that go back to that point. So if you're storing historical dates, then you don't want to use that. You want to use the DATETIME2, and that will store dates that go all the way back to the beginning of the calendar, essentially. So often I do end up using DATETIME2 in case I've got more historical dates. And that gets around that issue. Next we can have Boolean values. So let's put Boolean as a category, and in order to say true false values, so 0, 1, etc. In SQL we use the bit data type. So bit is going to signify whether this is true, false, or 0 and 1. And finally, in SQL Server, it's also got some geography data types. So let's type geography. And there's 2 types of geography that we can use. First of all, we can use geometry. So geometry will store points on a map which are Euclidean. So that means if you get if you go to the shop and you buy a map which is flat on a piece of paper, then it will plot points as if it's a flat Earth, as if so it flattens and warps the geometry slightly. You can also have a geography data type. So let's type geography. And that will store points as a round system, so it's non-Euclidean and not non-flat. So the shortest point between paths is not necessarily a straight line in a non-Euclidean system. So if you want to use true distances between points, then use geography. If you want a flat Earth representation, then you can use geometry. But those are not necessarily available in every database, but they are in SQL Server, and there's some limited functionality that you can use to, for example, work out the distance between 2 points and that type of thing. So the next thing we're going to look at is how to convert data from one type to another. And if you'd like to do that, then I'll put a link at the end of this video. So I've also got all these courses are on my website, which is www.padsresearch.co.uk. That's Physics, Aviation and Data Science Research. And I've also got another course, a complete course in SQL, which goes into all these areas in more detail and takes you through more advanced topics as well. And you can also find a link to that at the end of this video and also on my website.